Hey everyone. So today we are going to take a look at this problem, closest equal element, right? So the problem is straightforward that you are given like the problem statement, right? I'm not undermining the question. So you are given this 1, 2, 3, 4, 5, 6, and for each queries, right? You are saying that the element that is at that index. So let's put queries also there. So element at this 0 10 that which is 1, right? So element at 0 index is 1 and all the indexes that it is present is 0, 3 and 5, all the index. So element which is at 0, I want to find another element which are these and then see which is the closest distance. So here the closest answer is 2. Now at element 0 it's 4. And what are the indexes? 4, basically only 3, so that is -1. And then the index at 5, it's again 3, 1 and 5, right? So one way you can think of is this is 1 and 5, right? But they have also given that your array is circular, so this could be matched with your next element also. So the whole length of this is 7, so this is 5 and 7, that is 2, and then 1 from the start, right? That is like 2 plus 1, right? So that's the idea. Uh, that so basically when I was explaining, some hint or some idea would have already came to your mind. Like first thing is very simple that okay, you need to get this, right? You need to get this is O of n operation. Like for each element, we want to see all the indexes of that element, right? So for one, it will be 0, 3, 5. So for something like this, we can just use a hash map. This will be our index and this will be 0, 3, 5, right? Now, once you have done that, right, then so that's already O of n, right? Now for each query is 10 raised to power 5. So for each query, now how do we find? Like for example, for 3, how do we find? So here we already knew 1, right? And we already know our this array is sorted, right? So 0, 3, 5 is sorted. So whenever sorted is there, binary search will come into your mind, should come into your mind. So here I know that, okay, zeros index if I can find, the closest will be only either this or this. There are only these two options. If it is first, if it is last, either this or this. Only these are the valid options, right? So, and binary search is log n, right? So, and here n is even the indexes. So that's where you can have a outer loop as n and inner loop as log of n. So that will both be combined and it will give us n log n, so which will work in our constraints, right? So this solution will be posted after once the contest ends. I'm just recording it as it is going. So now let's quickly code this up. So first of all, we need to have a hash map with all the indexes, right? We can just call it hash map only, hm, right? So this is our hash map and now we'll quickly go through all the elements nums.length I plus plus. Let's initialize nums.length also. Now, once you have done that, right? So basically, you'll see html.put if absent. Then you are saying that okay, nums of I. If it is absent, you add array list, right? After that, you'll say hm.nums of I, and then add I, right? That's the index. Now, our answer is I think integer here. Sorry, list. So array list, right? And then for int I is equal to 0, I less than queries.length I plus plus. Now int index is equal to queries.I, right? Int element is equal to nums of index, right? Now list of all the other indexes, right? are, or all the positions, let's call this positions, is hm dot get this element, right? And this will never be null because at least one element is coming once, right? Now, if position dot size is equal to 1, there is only one entry, then answer dot add minus 1, right? Straightforward. But if that is not the case, you will do a binary search here. So here low will be 0 and high will be number of elements that you are doing a binary search in, while low is, now what we are trying to do is we are trying to find the index in this position, right? So we can call it as p in index in this position, right? While low is less than equal to high and mid is equal to high minus low by 2, right? Now, if position dot get mid is equal to position dot get mid is equal to index, because index we already know, we are trying to find the this index, right? So our p in will be mid, and you can break this, else your p in, else you need to check two things, right? So else if else if position dot get mid is greater than index, so you need to go to the left. So high is equal to mid minus 1, else low is equal to mid plus 1, right? So this is our binary search. Once we are here, so we have already got our p in value. Now here p in could be first, it could be last, it could be in the center, right? So based on that, we need to check. So we can say our option, I like to call it our, or you can say sub answer is integer dot max value, thinking that, okay, this is the maximum distance, right? Now, if p in is equal to 0, there are, first option is that it could be this with the last element, right? So sub answer is equal to math dot minimum sub answer. Now we already know that it is greater than 1, right? So what we can do is whatever is the position get 0, because it is 0. You can call it p in also, plus the last element, right? Last is going to add the n and the size, right? Size minus 1. That is our first option. And second option is if p in is equal to position dot size minus 1. This is the last option. So sub answer will be mat dot min sub answer. And then basically you are doing the same thing. Would get pin, right? And here it will come 0, right? You're getting the index of first element and then you are seeing position dot get p in, right? So, and now there could be the case that if it is, there is, so now it is 0 and it is not last. So it is something in the middle, and we know that there is, there could be either left or it could be right, right? So if p in plus 1 is less than position dot size, these are the simple ones. Mat dot min sub answer is equal to position dot get p in plus 1 minus position dot get p in. If pin minus 1 is greater than 0, equal to sub answer is equal to mat dot min sub answer position dot get p in plus 1 p in minus position dot get p in minus 1, right? Again straightforward. So once you have gotten all this, basically once you have done this, then you're seeing answer dot, this all is here, So here you will say answer dot add sub answer, right? And then you say return answer. So that this could maybe optimize, but I'll go with this for now. Okay, seems to run fine for this. Let's do submit. Yep, cool. So here this is important. These all the cases, right? So that's it for this problem. Thanks.